Euler's identity. Euler's identity is e to the I pi equal -1. Okay, so how do we get to Euler's identity? Right? This identity comes from special case of Euler's formula. Anyway, Euler's identity is one of the most beautiful thing in math because it's simple. Okay, what is Euler's formula? This is e to the I, which is the same, but here theta equal cosine theta plus I sine theta. This is Euler's formula. Then, as I said, Euler's identity is a special case of Euler's formula. What does this mean? If we use the pi instead of the theta, it's going to be the theta is going to be pi. Then the formula is going to be pi equal cosine. Then we use pi instead of theta plus I sine pi. Then cosine pi, which is -1, plus since sine pi is 0, it's the I times 0 is 0, so it is -1. That's it. Then some people might think how we get Euler's formula. Let's look at some Taylor's expansion. In order to know how we get Euler's formula, we need to know some Taylor's expansion. Okay, first example is e to the x. Taylor's expansion of e to the x, which is 1 plus x plus minus 1 over 2 exclamation, then times x squared plus 1 over 3 exclamation x cubed plus 1 over 4 exclamation x to the 4 plus it's continuing. Then next let's look at sine x. Then it is x plus, oh no, it's minus 1 over 3 exclamation x to the cube. Next plus 1 over 5 exclamation x to the 5. Then next negative minus 1 over 7 exclamation then x to the 7 plus blah blah blah. So denominator is a odd number. The next cosine. This is Taylor's expansion is going to be from 1 minus 1 over 2 exclamation x to 2, next plus 1 over 4 exclamation and x to the 4 minus 1 over 6 exclamation x to the 6 plus blah blah blah. Okay, that's enough. Then if we substitute, let's use iy, right? And then we can use iy instead of x. What do we get? Here, e to the iy equal, what's it's gonna be plus we use iy instead of x, and next plus 1 over 2 exclamation, then this is iy 2 plus 1 over 3 exclamation, then iy cube plus 1 over 4 exclamation, then not the x, the iy 4, then let's continue. Plus 1 over 5 exclamation, then iy, then 5 plus 1 over 6 exclamation, and iy, of course 6 plus 1 over 7 exclamation, iy 7 is going to be continue. Okay, then we can rewrite r1 same plus iy still same. Then here let's calculate this. Since there is a power 2, so I is going to be minus 1, right? I times I, which is minus 1, so let's put negative. Then 1 over 2, we don't need to calculate this one, just leave it. Then y is 2. Then here, as we have 3i, so minus, but we still have I, 1i, then 3 exclamation, then y is going to be 3, power is 3. Okay, if we do this, then 1 over 4 I4, then it's going to be plus 1, no, it I5 exclamation, y5, the next one minus, then 1 over 6 exclamation, then y6 negative, I7 exclamation, y7. Okay, this is I to the iy. Then do you agree that we can separate terms which have I and the terms which don't have I? Okay, so we use red line for the term which don't have an I. This guy, and this guy. Then I use blue for the term which have I. Okay, then we can rearrange again. Let's use red first. 1 minus 1 over 2 exclamation, y2 plus 1 over 4 exclamation, y4 minus 1 over 6 exclamation, y6 blah blah blah. Let's continue. Okay, then next I use blue. Plus iy minus I over 3 exclamation plus I over 5 exclamation y5 minus I over 7 exclamation y7 plus dot, dot. So let's take I out here, so cancel and then put parentheses, then put I out. Okay, then do you agree the red term 1 minus 1 over 2 exclamation y square blah 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 is this is a cosine y. Then blue one, I times this part is sine y. This is what we did before here. We use y, but the form is exactly same. Let's go back. Okay, so the totally e to the iy called cosine y plus I sine y. Then we can change y to the theta. It's going to be e to the I no theta equal cosine theta plus I sine theta. This is a Euler's formula. This is how we get the Euler's formula. How beautiful it is, right?